Yeah, happy Monday.
Hey Joe, happy Monday. Happy New Year.
Yeah, happy New Year to you too. Did you have a good New Year?
Yeah, it was pretty low key. Some text messaging, some Zoom calls, stayed up till midnight. That was about the extent of it. So,
Sounds riveting.
yeah, well, what can you do? That's about all you get right now. So,
Yeah. I don't think I was gonna go to like a giant party or anything like that. So
there must be still some underground raves going on somewhere, right? Like,
probably, yeah. So, but
that's a bad idea
we'll leave that to whoever wants to do that, I guess. So
for the kids. Yeah.
yeah. Um, well, awesome. You want to lead off with what we want to talk about this week?
Yeah, I think we want to discuss the difference between an analytics-oriented database and more traditional databases that you might be used to if you come from a software development background. And we want to talk about this because it's an issue that we see again and again. And so if you have developed web apps in the past, then you've probably used things like MySQL or Postgres or SQL Server to back up those web apps. And there are other types of databases that are better for analytics applications. And we want to talk about what defines those differences and why you should consider adopting one of these other types of databases if you intend to do analytics or data science. And even amongst data scientists and people who are pretty good at data in general, there's sometimes a lack of understanding about these differences. And so that's what we're going to dig into. It's a bit esoteric, but it's also very useful, I think.
Yeah. This is definitely something that we come across. I would say very often.
Yeah.
The call is typically uh, our data warehouse is really slow or it isn't working
Exactly.
anymore. And it worked last week and now it stopped working. And then
Or
when
my
we,
application is slow because I'm running analytics queries.
that's
That's
another
another
one. Yeah, exactly. So, and when we dig into the architecture, commonly, yeah, they're using a transactional database for analytical purposes. And the temptation, I think, is to use transactional database for analytics is I think it's understandable, right?
right.
Like you can get up and running really quickly. The data is typically in the database already, so you can just query it. That's awesome. And if you need answers like right now, I think that it makes a lot of sense to maybe try that route. I think what we're going to dig into though is inevitably what you're going to run into is it'll stop working at a certain scale.
Yeah.
So
It's familiar, right? But it's not going to scale in the same way. So transactional databases are designed to scale transactions. In other words, they're designed to process a lot of hits on the database very quickly. So like account updates and reads of account information very, very rapidly, thousands of times per second. But they don't scale in the sense of storing massive amounts of data. You start getting into terabytes and eventually petabytes. They're just not going to work all that well. And there's some kind of tricky ways of clustering, for example, Postgres, but it's not for this type of application. Postgres row-based database is just not the optimal solution.
mm-mm. No, the same would go for MySQL, Oracle, and then SQL Server.
Yeah,
We see a lot of SQL Server out there being used for data warehouses, and I think that this was the traditional approach. I would say until recently, where because I would say 10 years ago, 15 years ago, your options are really to invest in on-prem
yeah.
data warehouses, which were horrifically expensive,
Oh yeah.
millions of dollars for an implementation. And so your only option really was to stick with the transactional database and just try and make it work, right? So we see a lot of SQL Server data warehouses that were spawned around that time, 10, 15 years ago. And I would say around 2013, you know, Redshift came
Yep.
onto the scene, and that really did change quite a few things. And since then, you've seen this explosion of, I would say, readily available, easy to use, cloud native data warehouses.
And cheap and low overhead. Like they kind of check all the boxes that you really could never check with these traditional analytics data warehouse solutions.
Mm-hmm.
Like I think it's important to give solutions like Teradata a lot of credit, right? Teradata came out of a Berkeley research project in the 70s. It came out in like 1979. They were doing clustering before anyone else. But I think for the most part, if you're talking 2021, Teradata is making some efforts to catch up, but like it's a lot of management overhead. It's very expensive, whereas you can use Redshift and just turn it on and it works. And what were you saying the base cost is like for the simplest installation of Redshift?
I think for a single node cluster, last time I checked, and obviously the numbers are going to be different.
Right.
If you ran it 24 hours a day, every day, I think it was like $180 a month or something like that, which is pretty cheap. But then now you can pause your instances, which you weren't able to do before, right? So that reduces your charges. So I think it's really depends on like just how often are you running your data warehouse, right?
Exactly. Yeah. And then it's funny, like Google BigQuery came out about the same time as Redshift, but I heard about Redshift way before. And that's partially because it was Google Cloud and everyone back in the day, and still to some extent, was on AWS. And second, I think Google's messaging early on just wasn't quite as clear. I mean, I remember reading documents about BigQuery, and I was just never actually quite sure what it was when I was reading about it 5, 6, 7 years ago. Whereas Redshift, everyone was talking about it like, oh yeah, it's awesome. You just turn it on. It's an analytics database. You can process terabytes of data very easily. It's cheap. There's almost no management overhead compared to these other solutions.
Mm-hmm. Yeah, and I mean, I've done the the Postgres data warehouse in AWS, spinning up Postgres on a VM, and then putting a data warehouse in there, and then we migrated to Redshift, and I would say the performance was night and day. We ran into scaling issues early with that Postgres data warehouse. Again, the reason we set it up that way is because it was familiar technology. We weren't really sure that we wanted to commit to a dedicated cloud data warehouse. Again, this was many years ago, and it was just easy to get spun up. I mean, we could spin up a Postgres data warehouse, in a matter of a day. And I would say those same arguments can now be used for cloud data warehouses as well. So you can get spun up very quickly if your data is modeled correctly. I mean, you can have a data warehouse functioning, I would say, in a matter of days.
Yeah,
or less.
And in fact, so, I mean, how long does it take to turn on Redshift? It's like, what, 10 minutes, maybe less?
Right. Same with BigQuery, right? BigQuery is, I would say, awesome in the fact that you just give it data and just get going, right? Like
it's really basically an always on. Mm-hmm. Yeah, exactly. And then you have a CSV, you've got a table. Yep. Right.
And so you start seeing these different consumption models too. I would say like the pricing models have been interesting to watch unfold. You have BigQuery, which is just pay by query. Redshift was typically just pay by node and storage. And Snowflake came into the scene and separated compute from storage, and they're based on credits, whatever credits are. And then you had Athena come out on AWS, and that was consumption based, similar to BigQuery. And then Synapse, on Azure, that's now both serverless and pay for compute node.
And the serverless is exciting. I frankly need to sit down and play around with it more, but I think that seems to be the drift of the industry as a whole. We're going to see more and more serverless, maybe from Snowflake eventually too. I don't know. Mm-hmm. But for like small, companies that just need to consume a few analytics queries, serverless could make a lot of sense for them too.
Yeah, for sure. And so, I would say that, whereas a few years ago, a few being like even up to 6, 7 years ago, I think you could make a pretty strong argument about having a data warehouse on a transactional database. I don't know. I'm kind of at a loss to figure out like why you would do that these days.
Yeah, I think it's just social capital to some extent. What I've seen again and again in various jobs is that if someone is formerly a web developer and they've stood up Postgres before MySQL and is familiar, then it's very easy for them to stand that up again. But I think at the same time, it behooves us all to get more education in the area and to realize that it's actually far, far easier to stand up BigQuery once you know what BigQuery actually is and once you know the basics of how to turn it on. And to turn it on, you just create an account. That's it. So Yeah, it's just a matter of familiarity and like socializing that information about the basics of analytics. And the funny thing again is that I've seen data scientists kind of make the same mistakes, and that's because they're used to working in Pandas on their laptop, and so they
Yep.
don't necessarily know about database technologies for analytics.
Yeah, that's a good point too. I mean, you see a lot of these tutorials out there where data science tutorials,
Yeah,
where it's like spin up a Flask
yeah,
server. What else? Spin up Postgres or a database and put all your data in there. And I think that's fine for personal projects or something like that. But even then, I can make a pretty strong argument that spinning up BigQuery and using that for a personal project is um, probably more cost effective, right? Or spinning
absolutely.
up Athena and using it for your projects, because it's like these engineering teams at AWS, Google, Azure. I mean, they've spent a lot of time building this technology and they
Oh yeah,
maintain it for you. And especially with like BigQuery or Athena, where you're paying $5 per terabyte scanned, and then
yep.
you're maybe the cost of storage, which is negligible. It's like, what's your time worth at the end of the
Well,
day,
and the first terabyte is free. So
right?
if you're just a data scientist working on analytics and you need to like store some data in a relational database and just pre-filter and pre-process, do some joins, you probably won't pay anything for BigQuery until your data starts to get a little bit large. The kind of stuff you process on your laptop is going to be free and
Mhm.
very low overhead to manage.
Yeah, yeah, for sure. And the pandas thing drives me nuts too, because I mean, again, it's great for personal projects, but when you try and do that on data, at scale, I mean, you run into memory issues with pandas.
Mm-hmm.
Um, I mean, you could try and use Spark or Dask or something like that. But again, when you look at the types of queries most people do in analytics or even data science anymore, it's SQL is probably sufficient. I think it might be
Yeah.
controversial, but uh, I
Yeah,
would
and
say probably
again,
enough.
I think we just need to socialize better SQL skills in general and the use of some basic techniques like composition of different queries and such to do complicated things.
Hmm. I
Yeah,
think on that note too, socializing the differences of how you want to approach, a dedicated analytical database, a data warehouse versus, um, a transactional database for developers, right? Because you'll see developers um, try and treat Redshift or BigQuery the same as they would their application
yes,
database, and they're definitely not the same things.
not at all. Yeah. I mean, one of the big differences between state of the art analytics versus state of the art transactional is that generally analytics databases these days are column oriented. And column oriented databases are awesome when you need to scan a lot of data. So, in other words, if I'm running a statistical query where I'm going to scan a million rows each time I run the query, column database is probably the way to go. On the other hand, if I need to look up a single record, then row oriented, so like a traditional MySQL database is going to be way, way better for that. Like if you try to do individual lookups in BigQuery thousands of times per second, it does not work because what
Mhm.
happens each time you end up scanning a ton of data, like you don't have indexes on a column oriented database, which might sound like a bad thing. It's a very good thing if you want to scan. It's a very bad thing if you want to do individual record lookups.
Oh yeah,
Yeah.
and also updating and
Yeah.
upserting and these other behaviors. I think we're of the opinion in modern cloud data architectures, inserts are
Yep.
actually much better to do. We definitely don't advise doing upserts unless there's a really good reason to do it. And it's basically because of the architecture of how these data warehouses are designed,
You're right.
right? So again, when you're trying to update a bunch of rows in a regular transactional database, it's fairly easy. That's what they're for,
Yeah.
because each update is a transaction. When you try and do this in an analytical tool, the way that the underlying technology has to like reshuffle the data and partition and everything else. It's just it can lead to performance issues for sure, and it's
Absolutely.
unnecessary. I would say for analytics, you just got to approach analytics differently than you would um, you know applications.
Yeah.
So
Yeah, that's exactly right. Yeah. I mean, one thing to understand about technologies like BigQuery and Snowflake is that these use what's called copy on write. So what that means is that if I have a data partition, or in Snowflake we call them micro partitions, and I want to update it, it has to rewrite the entire partition. And so sometimes upserts can be okay. You just need to understand what you're doing. Like doing upserts every 15 minutes might be okay, but understand what the architecture does. If you're trying to do upserts several times a second, that's a nightmare, like because it's rewriting those partitions every time. Just
Yeah.
getting off into technical weeds for a second.
Well, I mean, on that note too, if you have a relational database and you're moving that data into a data warehouse, one recommendation that we offer is change data capture,
Yep.
right? So just and there's great technologies out there that can do this, like Fivetran, HVR, even the clouds have their own change data capture technologies. But essentially, what that is just moving the logs of your transactions into your data warehouse. And what that means is then you don't have to keep updating
Yeah,
data.
exactly.
Right? It's just a stream of every time there's a transaction that gets written over, and you have that history. So that's kind of nice.
Yeah.
Yeah, definitely. It's just yeah. I would say that's a big thing that we see is when companies start out with a new OLAP system in the cloud. They try. I see this over and over where they think, oh well, it's just a database, right? So we'll just treat it like our MySQL or SQL Server database. And it's definitely not the same thing. One cool thing on SQL Server, by the way, you can do is set up temporal tables. This is a little known thing where SQL Server is pretty cool in this way. So you can set up a table and it'll actually do the same. It'll actually do a better job than CDC in the sense where it just keeps track of all the transactions for that table. And then you can just put your data warehouse and just read from that or just pull it in. That's pretty cool.
Which is very cool. Yeah.
Yeah. Oh, go on.
Oh, I was just going to say, like Snowflake and BigQuery support some features like this where you have all these point-in-time snapshots, but they're batch point-in-time snapshots. So they just they give you a snapshot every time there's a commit. And unlike SQL Server row-based, they're not going to do a commit, many times a second. They do commits every few minutes where they batch up a bunch of operations.
Yeah.
So for just keeping track of history and analytics database, that can be fine. On the other hand, if you want to know the state over time of a database that's changing, where you're constantly making changes, then the type of solution you're talking about is much, much better.
And I would say the other piece of advice, which we've hit on in other data chats, is use ELT. Don't do ETL. I would say the arguments of doing ETL these days, I really can't get behind those arguments anymore. I would say that maybe before the advent of cheap storage and separation of compute from storage, it made a lot of sense to do ETL. But these days, I can't really see. I'm sure there's reasons, but you'd have to think pretty hard about them. Like maybe you want to transform your data in flight, but that makes more sense for a streaming system. But even then, I would say we want to keep a copy of the raw data somewhere, right? And so that's some advice is just set up a staging area in your analytical data warehouse, and just load your raw data into that, and then use the power of your cloud data warehouse to transform that data within the data warehouse. This is a very common pattern. Extract, load, transform, ELT, and highly advise doing that, because that's another thing we see is where an application developer might feel that maybe we'll just transform the data and then load it into the data warehouse. And if you look online, there's a ton of articles about that because it's how it used to be. It's how it's done. Still a lot, which is ETL. But our advice is actually do the opposite, do ELT.
Yep. And I think in some practical applications with clients, what we do is say, try to do whatever you can in SQL in terms of data transformation. And if you run into something really hairy in terms of complex analytics, then maybe for a few jobs, you do a more traditional ETL, and you use a framework like Spark, or we like Google Cloud Data Flow, for example, which is Apache Beam, where you're pulling it down to a new system that maybe is more suitable for certain types of statistical analytics situations where SQL starts to bog down. But otherwise, just make SQL your default. And then you have this common lingua franca across all kinds of different jobs that you're doing.
Yeah, that's a good point. And on that notion too, I mean, you bring up using Spark and Dataflow, which sort of necessitates taking the data out, transforming them, putting back in. I mean, what are the cost advantages of just doing in-place transformations in your data warehouse versus using an external system?
Yeah, and I think usually as long as the transformations aren't too complicated, it's far, far more cost effective. I mean, one of the sneaky things with BigQuery is that you only get charged for what you read. So that means that you're not actually getting charged for processing. So you can do some pretty complex CPU intensive stuff without spending extra money. Now, the downside is that if you're kind of pushing up against the limits of what SQL can do, then the job might run so slow with SQL that it just isn't worth it. But I think in general, my recommendation would be make SQL your default, see what you can do in SQL. If it's too slow or too complex to write the SQL, then might maybe start thinking about a separate framework. But to your point, the problem with these frameworks is that you're spinning up separate ad hoc clusters. You're going to spin up a data flow cluster or Spark cluster, and that's going to cost extra money. And then it also entails some management overhead to have those separate assets running.
Mm-hmm. And you can do the same thing in Snowflake. I would say that
Exactly.
Snowflake's actually awesome for this, right?
Yeah.
So you can just spin
No,
up a virtual warehouse for your transformations. You can spin up another one for your staging data
yeah.
and so forth. And that's a big advantage. Redshift is an interesting one where I think they're getting better at this, but
Yeah.
for the longest time it was super monolithic. And so, in order to have sort of separations of concerns, you'd have to set up different clusters.
Yeah.
And that could get expensive. And I've seen cases where Redshift has been brought to its knees because the same data warehouse that people are querying is also the same data warehouse where there's transformations going on. And that's, um, so I think it's improving a bit, but, to be frank, I think we see people kind of moving away from Redshift until maybe some recent announcements just because of that. Like at a certain point, it's like, well, I mean, you can make some optimizations in Redshift where you could just go to something like BigQuery or Snowflake where, it's just going to perform a lot better. So, and again,
Yeah.
not a knock against Redshift. I think they're definitely making some great improvements in that area, but, there's just stuff that we have seen on the ground. So,
Absolutely. I mean, the fact that you couldn't have two different warehouses querying the same data easily, and you couldn't have ephemeral warehouses in Redshift. I think Redshift deserves a lot of credit. Back to what I was saying earlier, when it came out, it was just awesome. It blew people away. I think at this point, Amazon is making a lot of investment in improving it, and maybe eventually doing more to separate compute and storage. The landscape in Redshift is still very complicated, but I'll be curious to see what Amazon does in the next couple of years because they're Amazon, like they're the 500-pound gorilla. They can do whatever they want. They have as many resources as they want at their disposal.
yeah, for sure. Cool. Anything else we want to cover on this topic before we cut out?
I think that's about it for now. Yeah, maybe we'll get some follow-up questions which we can answer in a subsequent chat.
Yeah, awesome. Well, cool. Until then, I'll see you next week and enjoy your Monday. So, and
Will do.
yeah,
Happy New Year.
Happy New Year to you. Yeah, and for the audience, if you like this video, please like and subscribe to our channel. Keeps us going, and yeah, we'll see you next Monday with everything. So, take care.
Take care.